Hi everyone, my name is Nurul Ayuni Mohamad Rosli. This video is for the assignment D Meriam 2300. In this video, I will talk about the work energy for rigid bodies. The equation to be used in this topic is derived from the work energy equation. The total work done on a rigid body is the sum of the work done by the external forces and the work done by the external moments. Delta T is the change in kinetic energy, while the delta Vg is the change in gravitational potential energy, and the delta Ve is the change in elastic potential energy. Remember that we have learned before the Ke for a particle is T equal to half mv squared. Then for a rigid body, you can find Ke by summing up the Ke of every point in the body by the integration over the body. And we know the velocity of any body is written as Vp equal to V bar plus omega times r. Then after we substitute back into the integration, we will get T equal to half mv squared plus half I omega squared. The first part is for translation and second part is the for rotational motion. This idea is originally from Samuel. Before we proceed to the derivation, let's have a short quiz. Yay! Samuel Coley has beard or no beard? The answer is no beard. Okay, let's continue to our derivation. Change in gravitational potential energy is mg delta h, and the change in elastic potential energy is half k delta x squared. To make it more clear, let's do an example. From the equation, we are given that the distance of AC and CB are 0.25 meter, DB is 0.5 meter, and the height is 0.9 meter. We are also given the mass of the rod, the stiffness of the spring, and the original length, and we need to find the omega at the vertical position. Firstly, let's write our work energy equation. In this equation, U prime is 0 as it has no external forces or moment. For kinetic energy in this case, we only deal with the rotational part, so our change in T is half IC change in omega squared. Since omega 1 is 0, so delta T is half IC omega squared, where IC is I bar plus md squared. For the rod, the I bar is ml squared on 12. So we just sub in the value here, and then we get delta T is 0.2915 omega squared. So for change in gravitational potential energy, we need to find the delta H. As T is the center of the mass and it's rotated about C, so our delta H is just CV. So it is 0.25. And then we get delta Vg is 9.81. And the next step is we need to find the change in elastic potential energy. Remember that x2 and x1 are the length of displacement of the spring. To find x1, we need to find L1 first and subtract the original length. And same for the x2, we need to find the final length of the spring. and the x2 is equal to L2 minus original length. And we substitute back into the delta V equation, and we get delta VE is equal to negative 19.325. And finally, we substitute all of them into our work energy equation to find the omega. And the omega is 5.7133 radian per second. That's it. Thanks for watching and good luck.